Welcome. Here we are today with Mitch Gregory from All EV. He's one of our Dalhousie engineering students. And we have an exciting day today with some video we're going to be doing. And what are you actually going to do today, Mitch?
So what we have here is a Tesla Model 3 drive unit. On the left we have the subframe and suspension that the drive unit sits in. We've removed the drive unit and we're going to completely disassemble it and show you what's inside of it. Okay, so we're in front of the motor now. We have the entire subframe with motor, axles, suspension, everything all in one unit. Really well packaged. It's pretty impressive how Tesla did it. We're going to look at the drive unit specifically. We've got our front right motor mount, front left motor mount, and then a rear mount. It's only mounted in 3 spots. Around that we have our cooling cables that go to our cooler. We've got our high voltage connector. There's no battery, so this is it's completely dead. It runs up to the plug up on the face here. Down below we have a low voltage connector, which has 30 pins on it. And then we have some cooling for the inverter. So this is the inverter cooling, and then we have the oil cooling over here. They run in series. So the coolant that goes into the oil cooler also goes through the inverter. So this is what it looks like in the rear subframe. And we're going to remove it and show you what it looks like on its own. We've got the drive unit on the stand. We fabricated this out of a piece of pipe and some steel bar, welded her up. And now we can rotate this motor in different positions and take parts off. The first parts that we want to take off are the cooler and the front left mount. There's a little clip. Once you pry that out with a screwdriver, you can pop that off. There's a couple clips. It's a tough one. There's one more down here. It's already been removed. And then 2 bolts. There we go. That guy there. Next up, we're going to remove the front left motor mount. Before I pull the last bolt, I'm going to lay this on its side and I'm going to lift the casing up vertical. It's much easier to do it that way. Okay, so before I remove this casing, we're going to remove this bearing plate. It has a couple bearings for the input shaft and the secondary shaft, and there are 7 bolts. There we go. Gasket. And it's really important not to lose these little washers. Okay, one more bolt. Now we can remove the case. So in order to remove the case, you just have to wiggle it. It's a little tricky, but lots of wiggle. And the case is off. The input shaft is trying to come with it. Okay. And just bring it with it. There we go. And then 2 of these have to come together. There's this plastic guard that holds it. Okay, so we've removed every single component from this drive unit. Now I'm going to put it all on the table here and tell you a little bit about how it all works.
Part looks fantastic, the amount of engineering that's gone into this, and the teardown. The teardown looks awesome. You got it laid out nicely. Maybe explain what all these parts are now.
Cool, so I've arranged it in a way that, that I should be able to explain a little bit how it works. So to start over here, we have our high voltage cable that brings high voltage DC current to the inverter, and inside this inverter we have the brawn here and then the brains over here. So this is basically the controller, and this is what inverts the DC current, which comes in here, goes into a capacitor bank, and then is switched back and forth to create sinusoidal waves that are then passed to the motor. Now we have to cool these triggering MOSFETs, and that's what this manifold does. So we saw earlier the heatsink, and this manifold passes coolant through the heatsink. Now that's sealed, so the circuitry does not get damaged. And like I said, we have it's an AC motor, so we have sinusoidal wave, 3-phase, going to this stator. And what that does is the coils create a magnetic field that reacts with the magnets, these neodymium magnets. Do you have that metal stick?
Right there.
Take a look at it.
Like right from here.
Yeah.
You can feel the strength.
So the magnetic field induced by the stator reacts with the magnetic field on the rotor, and that produces a torque. Then we get a torque multiplication. In this case, it's about a 9-to-1 multiplication through the gear set. And then we have our axles that go on this side and then one on the other that go out to the wheels and allow us to move forward.
And this kind of differential here, what is that?
Yeah, so actually this is an open differential, so if one of the wheels were to spin, the other one wouldn't quite get the torque it would need, but that's kind of counteracted with the brains in the Tesla control unit. So yeah, pretty standard, not really a high performance differential, but Tesla makes it work with their control electronics. That kind of explains how it all works, but then there's also some thermal control and oiling that happens in this drive unit. That's pretty interesting. So, contrary to popular belief, Dave, we do have a filter. Right. So there's a pretty standard filter, oil filter. What happens here is we have our oil pump, which picks up from the bottom, from the sump of this drive unit, and it pumps oil, high pressure oil, through this little this port here, which passes into the outside of the filter. It passes through the filter, going to the inside, and then it's pumped through a little tube on the inside.
That's right.
Of the casing.
It looks like just a standard oil filter.
Yeah.
So it probably has a relief valve inside, some sort of valve to prevent it from getting plugged up.
Yep. So that pumps clean oil up to the cooler. So the oil is then immediately cooled after it's pumped. We have a heat exchanger where glycol, what was the
G48.
G48 coolant passes through the heat exchanger. The oil and the coolant are in separate chambers, but they're able to transfer heat between each other. So the coolant is cooling the oil. Once it's cooled, it goes two places. One, it goes to the stator, and the other one, it pumps it through this tube, and it oils the input shaft and secondary shaft bearings. So there's a plate at the bottom here that guides the oil, and then eventually it returns back to the sump through this plastic guard, I guess it would be, kind of oil guide. And there's one more measure. Oh, get too close to the stator. There's one more measure. There's actually a magnet in the bottom that picks up any fine particles that come off with the wear of the bearings.
Almost like a regular transmission.
Yeah, the fill plug would have one, right?
Yeah.
Now there isn't. There's an oil filter, and when you pull the pump, you can drain the oil really easily. Yeah. But there is a fairly traditional oil fill plug, and then there's a breather valve on the top. So over here we have that breather valve. So that's kind of how the oil works. And then we have cooling through here and cooling through the inverter.
Okay, thanks for watching. Mitch did a great job here. One thing is, make sure you hit the like button and also hit the subscribe button. Follow us on Instagram, YouTube. Visit our website, www.allev.ca. And any final words, Mitch?
You can also follow me on Instagram, Electric Future MG. But we'll see you next time.
Great, thank you.